Hey there. Ever find yourself uh, going down these rabbit holes of AI-generated content? Like those eerily human-like texts that are like popping up everywhere.
Yeah, absolutely.
We're not alone.
Mm,
Uh, you sent in an article all about large language models,
mm.
those brainy tools like ChatGPT and GPT-4.
Right.
And we're going to take a deep dive into how they actually work.
Yeah, let's do it.
It really does feel like magic sometimes, doesn't it?
It does.
You type in a request and boom, coherent text appears.
I know.
But like the article points out, there's some serious engineering going on behind the scenes.
Yeah.
What's so fascinating is that this journey starts with something so simple. You know that blank box where you type in your request?
It does seem simple, but yeah, it's way more important than it looks.
That's right. It all starts with the prompt.
But the prompt is everything.
So a well-crafted prompt is like giving someone clear direction.
Exactly.
And a vague one is like saying, just wing it.
Right.
The results can be wildly different.
Yeah.
The article gives this great example. If you want to learn about, say, quantum physics, you could just type that in.
Sure.
But a more effective prompt would be like, explain quantum physics to me like I'm 10 years old.
Much better.
You see the difference.
Yeah, you're giving the AI a specific goal and tone to work with right from the start.
It's like setting the stage for the whole process.
Exactly.
Okay, so we've given our AI directions, but how does it actually understand what we mean?
Right.
That's where things get really mind-blowing.
Yeah, it is.
Our words need to be translated into something the AI can process, right?
Exactly.
Like imagine having to break down every sentence into its tiniest meaningful parts. That's essentially what happens next. It's called tokenization.
Tokenization, that's the magic word.
So if I say, the weather is nice today, you're telling me the AI breaks that down into individual words?
Yeah, like the weather is and so on.
Wow.
But it gets even cooler.
Oh,
LLMs, they often use this technique called subword tokenization.
subword tokenization.
Yeah, it's a bit like advanced syllable splitting.
Okay.
It allows them to handle complex or even made-up words by breaking them down into smaller units they recognize.
So instead of tripping up on a word like supercalifragilisticexpialidocious,
Right.
it can actually process it.
Exactly, because it breaks it down into smaller pieces that it's already seen before.
That's seriously impressive.
It is impressive.
So now we've got these bite-sized pieces of language on the tokens, all prepped and ready to go. But how does the AI actually make sense of them?
Right.
This is where we enter the world of neural networks.
The heart of the matter.
Neural networks.
Yeah.
That's where I usually start picturing like a science fiction movie and tune out.
It's easy to get lost in the weeds, but it's actually really fascinating stuff.
I believe you.
Think of a neural network, well, a network, right?
Okay.
A complex web of these interconnected nodes that process information.
Nodes.
Yeah, these nodes are kind of like mini decision makers, and the connections between them get stronger or weaker as the model learns.
Interesting.
It's all about recognizing patterns in the data.
So the more data you feed this network, the better it gets at understanding and using language.
Exactly. It's like the more you read, the better you understand grammar and vocabulary.
Right.
These LLMs, they're trained on absolutely massive data sets of text and code.
Like, how massive are we talking? Think like feeding it a library the size of the universe.
Okay.
Maybe even bigger.
I'm starting to get a sense of the scale here.
It's mind-boggling.
But there's one piece I'm still missing.
Okay.
How does the AI actually predict what to write next?
Right.
It's not just randomly stringing words together, right?
No, not at all. It's all about probability and something called self-attention.
Self-attention.
Yeah, imagine your phone's autocomplete,
Right.
right? But instead of suggesting just the next word, it could predict entire sentences or paragraphs based on what you've already typed.
Wow.
That's kind of what's happening here, just on a much grander scale.
So it's using the patterns
Yeah.
it's learned to calculate the most likely next word than the next, and so on, building an entire response piece by piece.
That's a great way to put it.
And this self-attention thing, that's how the AI keeps track of everything,
Right.
even across these long stretches of text.
Exactly. It's like having an incredible memory for everything it's ever read.
Wow, so it's almost like the AI is developing a form of reading comprehension,
In a way, yeah.
keeping track of all these different elements. Look, we do.
It can be pretty mind-blowing when you think about it.
Mind-blowing is right.
And the more sophisticated these models get, the better they become at mimicking human-like understanding of language.
It's really incredible. Okay, I'm starting to grasp how these LLMs work, like on this basic level,
Yeah.
but it still seems like some are way better than others, you know?
Right.
Some AI-generated text is surprisingly good, while other stuff, not so much.
True.
What makes that different?
Well, the article actually dives into that. And it kind of boils down to three key ingredients, if you were.
Hit me with those secret ingredients.
Oh, I've already touched on the first one.
Okay.
The quality of the prompt, just like giving good directions, is key.
Yeah,
A well-crafted prompt can make all the difference in the world.
makes sense. What's the second ingredient?
The second one is all about the training data itself.
Okay.
Remember how we talked about LLMs being trained on these massive data sets?
Yeah.
Well, turns out it's not just about quantity.
Okay.
It's about quality, too.
So it's like feeding a human brain.
Exactly.
A diet of nothing but comic books might make you an expert in superhero lore,
Right.
but you probably wouldn't ace a physics exam.
Exactly. The article highlights three key aspects of good training data:
Okay.
diversity, relevance, and recency.
Okay. Break those down for me.
Okay.
Diversity makes sense.
Right.
You want a wide range of styles and information.
Exactly.
But what about relevance and recency?
So relevance is about making sure the training data aligns with what you want the AI to actually do.
Okay.
So if you're building a chatbot for a bank,
Right.
you probably don't want to train it on Shakespearean sonnets.
Makes sense?
You want it to be well-versed in, like, financial language, customer service interactions.
Right. That makes total sense. And what about recency?
Yeah.
Is that why these AI models seem to need updates all the time?
You got it. The world changes fast, right?
Yeah.
New terms pop up, events unfold.
Right.
Training data can get stale quickly.
Yeah.
If you want your AI to sound like it actually knows what's going on, it needs to be fed a steady diet of fresh, up-to-date information.
Okay. So we've got the prompt, the training data.
Yeah.
What's the third factor that impacts how well these AI models perform?
The third ingredient, and this is where it gets a bit more technical, is the architecture of the model itself.
Oh, architecture.
Yeah.
We're talking about like building a digital brain here.
Kind of remember those neural networks we talked about?
Yeah.
Those interconnected webs of nodes?
Right.
Well, the way those networks are structured, the number of layers, how they're connected, all of that plays a huge role in how effectively the AI can learn and generate text.
So it's like some buildings are simple and utilitarian,
Right.
while others
Mhm.
are these grand, intricate structures designed for specific purposes.
Exactly. And in the world of LLM, some of those key architectural elements are things like the size of the context window.
Context window. Okay, remind me what that is again.
Sure, we talked about how self-attention helps the AI keep track of information, even across long stretches of text, right?
Yeah.
Well, the context window basically determines how far back the model can remember when it's making predictions.
So a larger context window means the AI can consider more information,
Exactly.
leading to more coherent and nuanced responses.
Right. It's like having a larger working memory.
Okay, that makes sense.
But of course, there are trade-offs.
Like what?
A larger context window requires more computing power,
Oh, right.
which can make the model slower and more expensive to run.
Fascinating. Are there any other key architectural elements we should know about?
Yeah, there's two more that the article highlights.
Okay.
Embeddings and parameters.
Okay, embeddings first.
Okay.
What are those all about?
Remember how we talked about tokenization? Breaking down words into those smaller units?
Right.
Well, embeddings are how those tokens are represented mathematically within the model.
Okay.
Think of them like giving each word a unique fingerprint
Okay.
that captures its meaning and how it relates to other words.
So similar words would have similar fingerprints.
Exactly.
Like happy and joyful would be closer together than, say, happy and anchovy.
You got it. And the richer and more nuanced those embeddings are, the better the AI can understand the subtleties of language.
Okay, that makes sense. And finally, we have parameters,
Yeah.
which honestly sounds a little intimidating.
Don't worry, it's not as complex as it sounds.
Okay.
Think of parameters as the knobs and dials that fine-tune the entire model.
Okay.
They determine the strength of connections between those neurons we talked about,
Right.
influencing how the AI learns from the data.
Okay.
More parameters generally mean the model can capture more complex patterns,
Okay.
but again, it comes at a cost of computational power.
So it's all this balancing act then.
Exactly.
Bigger context window, more parameters, richer embeddings.
Right.
They all sound great,
Yeah,
but they also mean more processing power is needed.
exactly. Building these LLMs is this constant push and pull between performance and efficiency.
We'll leave you with this final thought.
Okay.
If AI can now generate any kind of creative content imaginable,
Right.
what will you create with it?